Value mixture problems. These are word problems that set up in similar ways. Here we're going to do an example with tickets. In this video, we'll analyze a mixture problem where we know the quantities involved. Then we'll use our analysis to set up an equation for a problem with unknown quantities. We'll solve the equation and we'll write the solutions in terms of the original problem. Suppose you're going to visit an amusement park. Adult tickets cost $75 each. A child's ticket costs $50. Your group has 3 adults and 5 children. So how much will all the tickets cost together? To figure out how much the adult tickets cost, we multiply the number of adults, 3, times the cost of the ticket, $75. To find out how much the child's tickets will cost, we multiply the number of children, 5, times the price of their ticket, 50. Then we add those two together, and that will give us the total price. 3 times 75 is 225, and 5 times 50 is 250. These are prices in dollars, and if we add them together, we'll get the total price. It's going to cost this group $475. Now, here's a word problem about the same situation. A group of adults and children is visiting an amusement park. Adult tickets cost $75 each, and child tickets cost $50 each. But instead of knowing the number of adults and knowing the number of children, we have instead a relationship between those two. The number of adults is 3 less than the number of children. We also know the total cost is $650. We want to find out how many adults and how many children in the group. Let's set it up the same way we did before. The cost for the adult tickets will be the number of adults times the price of the adult ticket. The cost of the children's tickets will be the number of children's times the price of a child's ticket. And the total will be those two added together. Now let's fill in numbers that we know. We know the price of an adult ticket is $75, and we know the price of a child's ticket is $50, and we also know that the total is $650. So we filled in the numbers, but what about the number of adults and the number of children? Well, it should occur to you to use a variable there. Let's call the number of adults A, and let's call the number of children C. So now we have an equation. It says that 75 times the number of adults A plus 50 times the number of children C equals 650. But the problem is we can't solve an equation with 2 variables. So this is the place where we're going to use the relationship between the 2 variables. The number of adults is 3 less than the number of children. If I translate this sentence, it says the number of adults, A, is equals 3 less than the number of children. So whatever the number of children is, 3 less than that is the number of adults, C minus 3. For example, if 10 children are going, then the number of adults is 10 minus 3, which is 7. Let's rewrite, replacing A with C minus 3. Now I have an equation with 1 variable, and I can solve. Well, let's solve the equation we found, C minus 3 times 75 plus C times 50 equals 650. We'll begin by simplifying. We have 75 times c minus 3 plus 50 times c equals 650. If we distribute 75, we have 75c minus 3 times 75, which is 225, plus 50c equals 650. Let's gather the like terms. 50c and 75c is 125c, minus 225 equals 650. Well, now we can add 225 to each side, and we get 125c equals 875. Divide by 125 on each side, and we find that c equals 7. Since c stands for the number of children, we know there were 7 children. Well, now let's go back to the original problem. I know the number of children. It's 7. But I don't yet know the number of adults, and that's part of the question. So if I look at that original equation, I can fill in the 7 for the children, but I still don't know A. But remember, I have a relationship between the number of adults. It's 3 less than the number of children. So if the number of children is 7, 7 minus 3 is 4. Now I know that the number of adults is 4. Let's try those numbers in the equation to make sure everything works out. 4 times 75 is 300, so this part is 300. 7 times 50 is 350. So we have 300 plus 350 equals 650. That's true. We solved it. There were 4 adults and 7 children.